Let's say in a triangle, the two sides and an angle opposite to one of them is given to us. For instance, let's say we have the triangle ABC. Then the sides opposite to angle A, which is BC, will be denoted by A in lowercase. The side opposite to angle B, which is AC, will be denoted by B in lowercase. And the third side, which is the side opposite to angle C, will be denoted by C in lowercase. Now for this triangle ABC, let's say two of the sides are given to us. So let us suppose that B, the side B and the side C is given to us, and one of the angle which is opposite to it, let's say the side opposite, the angle opposite to side B, which is at the angle B, let's say this is given to us. These three informations are given to us. Now what can we say about the triangle? Okay, now if we take cosine of the angle B. So here what we are doing is we are taking the help of the cosine, law of cosines. Now cosine of angle B is given by, we take the sum of the squares of the adjacent sides. So that means the adjacent sides are side A and side C. So here we have C squared plus A squared, and then we subtract the square of the opposite side. That means B squared divided by 2 times the product of the adjacent side. So this is the law of cosine. Now, with the help of this law of cosine, what we'll do, we'll try to find out the measure of the side A. So let's do one thing, let's cross multiply. So that should give us C squared plus A squared minus B squared, and this is going to be equals to 2 times CA times cosine of angle B. Fine. So let's say this is known. Now next what we will do, we're going to rewrite the terms. So let's keep A squared on the left hand side and then transpose C squared minus B squared to the right hand side. Then also we're going to transpose 2 times CA cosine B to the left hand side, such that we get negative 2 times A times C cosine B. And this is going to be equals to, B squared minus C squared. Now what we'll do, we're going to add an extra term to each side. So here we have A squared minus 2 times A times C cosine B. So what we'll do, we're going to add C squared cosine squared B to both sides. So we have C squared cosine squared B, that's equals to B squared minus C squared plus C squared cosine squared B. So this is the extra term that we are adding on both sides. The reason why we are adding it, because on the left hand side what we get is a perfect square. So here we get A minus C times cosine of angle B whole square. So this is going to be now equals to B squared minus so let's do one thing, let's take negative C squared as the common factor from the second and the third term. So we have negative C squared multiplied to 1 minus cosine squared B. Now furthermore we can reduce 1 minus cosine squared B and change it to sine squared B. Sine squared B. Now what we'll do, we're going to take the square root on both sides. So taking the square roots, we get A times C times cosine of angle B. That will be equals to plus or minus the square root of B squared minus C squared times sine squared B. Now what we'll do, we're going to transpose negative C cosine B to the right hand side, which gives us A. So A is going to be C times cosine of angle B plus or minus the square root of, we have B squared minus C squared sine squared B. So here what we have obtained, an expression for the side A, or the measure of the side A. So here we have C times cosine of B plus or minus the square root of B squared minus C squared times sine squared B. Now clearly this is going to give rise to a couple of cases. We're going to specifically look at the expression underneath the square root. So let's look at the case when B value is less than C times sine of angle B. Now here, before understanding what does it actually mean, how we even choose here. So here we're going to consider the side that is opposite to the known angle. That means angle B that is known. So we take the side that is opposite to it, and then we take the other side C and multiply it to sine of that angle B. So that gives us C times sine of angle B. If B is going to be less than c times sine of b. Now, if we look at this expression clearly, we will get a negative number inside the square root, okay, so underneath the square root, which is going to make the value for a imaginary. Then this implies that a will be imaginary. A will be an imaginary number, or we can say it's a complex number. It's going to be a complex number. But we know that A represents what? It represents the side of the triangle ABC, and if it is a complex number, then that is not possible, which means that there will be no solution. This means that there will be no triangle. There will be no such triangle that exists. So whenever we get the criterion that B is less than C times sine of angle B, then in that case there will be no triangle. Let's look at an example. So we need to solve the triangle having side B equals to 50, C equals to 63, and the angle B equals to 54 degrees. Let's try to understand this with the help of a triangle. So here we have the triangle ABC. The letters A, B, and C in lowercase are the sides opposite to angle A, angle B, and angle C, respectively. Now, in this triangle, measure of B is given as 50 units, measure of C is given as 63 units, and the angle measure is 54 degrees. That is the angle measure of B. Now, here what we'll do, we will take the side C, which is adjacent to the angle, the given angle. So we'll take the product. So we'll take C times sine of angle B. So this is going to be equals to, we have 63 multiplied to sine of angle 54 degree. So let's plug this into a calculator, and that should give us a value approximately 50.968. And here we are given that the side B, that's equals to 50. Now clearly we see here that the measure of the side B, this is 50, but it's going to be less than the measure of C times sine B. So this is following the criterion which we discussed earlier. So whenever B is less than C times sine of angle B, this implies that no triangle exists. If there is no triangle, that means there is no point of solving the triangle. So no triangle exists. So there will be no solution for the triangle with the given dimension. Now we come to the other case. So let's say let this time B be equals to C times sine of angle B. Now what can we say about this particular case? Now when we substitute B with C sine B in this case, then A is going to be equals to C times cosine of B. So here what we're getting, we are definitely getting a solution, and it is going to be a unique solution. So what we're getting here is a case of a unique solution. So whenever we have B equals to C times sine of B. And also from the law of sines, we know that A over sine of angle A, that's equals to the ratio of the side B to that of sine of the angle B, equals to the ratio of the side C to that of sine of the angle C. This is referred to as the law of sines. Now in this law of sines, if we suppose that all of these three ratios common to a common constant, let's call it lambda, then what we can do, in place of B, we can replace with lambda times sine of angle B. This is going to be equals to, now we have C. So C is going to be lambda times sine of angle C multiplied to, we have sine of angle B. Now clearly what we can see here, the lambda gets factored out from both sides, also sine B gets factored out from both sides, and that leaves us with sine C equals to 1. Now what does it mean when we say sine C equals to 1? That means that C must be, this implies that C must be equals to 90 degrees. This means that in this case, whenever B equals to C times sine of angle B, then we have a unique solution, a single solution, and all for that, and also we have a triangle which is right angled at C. So actually, this is going to be a right angle at the angle C. So let's try to understand this idea with the help of an example. So let's say we have a triangle with side B and C are given to us, and B has an angle measure of 75 degrees. The B here is given as square root of 3 plus 1, and the C measure is 2 times square root of 2. Then we have that angle B, which is the angle opposite to one of the side, that is side B in our case. It's given us 75 degree. So we need to solve this triangle. Solving this triangle clearly means that we need to find out the angle measure of A, C, as well as the length of the side A. Okay, let us begin. So here, the first few things that we'll try to find out is, so we must show here that B equals to C times sine of angle B, if it is true or not. So here B is given as square root of 3 plus 1. That's going to be equals to, now C here is 2 times square root of 2 multiplied to sine of angle B. Now sine B, your B is given as 75 degree. So let's quickly try to find out the value of sine 75 degree. Now sine 75 degree can be also written as 45 degree added to 30 degree. Now we can easily expand this. So we have a standard formula for that. So we have sine 45 times cosine 30 added to cosine 45 times sine 30. Then we have sine 45, that's 1 over square root of 2 multiplied to cosine 30, that's square root of 3 over 2 added to cosine 45, that's 1 over square root of 2 multiplied to sine 30, that's 1 over 2. So that means sine 75 degree comes out to be square root of 3 plus 1 divided by, let's use this value, we have 2 times square root of 2 multiplied to square root of 3 plus 1 whole divided by 2 times square root of 2. Clearly 2 times square root of 2 gets factored out from the numerator and the denominator, leaving us with square root of 3 plus 1. So we have square root of 3 plus 1 equals to square root of 3 plus 1. Indeed, we can say that B is going to be equals to C times sine of angle B. Now if B equals to C times sine of angle B, does there any solution that exists for this triangle? Yes, definitely a unique solution is going to exist, and also it's going to be a right angle triangle. Now let's try to figure out which angle is going to be a right angle triangle. Now for this B condition, that B equals to C times sine of angle B, we can replace B with lambda times sine of angle B. That's from the law of sines. This is going to be equals to C. So C is going to be lambda times sine of angle C multiplied to sine of angle B. So that leaves us with sine of C equals to 1, or in other words we can say that C is going to be 90 degree. So here we have obtained the measure of angle C, so that's 90 degree. Now that we know a measure of angle C, since B is already given to us, we can immediately find out the measure of angle A. So here, since we know that A plus B plus C, that's equals to 180 degrees, the sum of the three angles of a triangle adds up to 180 degree. We can immediately find out the measure of A. So A is going to be 180 degree minus the sum of the angles B and C, and that is going to give us a measure of 15 degree. So A comes out to be 15 degrees. So we have successfully obtained the measure of angle A, and finally we need to obtain the measure of A. So either we can use the formula that we obtained earlier, or what we can do, we can use the law of sines. Better to use the law of sines, it will be much easier. So since we need A, so using the law of sines, we're going to take two ratios. We'll take A over sine of angle A, and we're going to equate it to B over sine of angle B. Fine. Which means that A is going to be equals to B times sine of angle A divided by sine of angle B. So B measure that's given to us, that's square root of 3 plus 1. Let's substitute it here. We have square root of 3 plus 1 multiplied to sine of angle A. So we just now found out the value of sine A of A, that's 15 degree, divided by sine B. So B is 75 degree. We have 75 degree. So using the same technique, you can find out sine 15 degree as well. We have already obtained the value of sine 75 degree. So we can substitute this, and this is going to give us the measure of A as square root of 3 minus 1. So that means for the triangle ABC, measure of A is going to be square root of 3 minus 1. So we have successfully solved the triangle. Now let's go to the next case. Now we come to the third case. Now in the third case, so previously what we considered that B is less than C times sine of B. Then in the second case, we considered B to be equals to C times sine of B, which yielded a right angle triangle. Now this time we're going to consider the case that B is greater than C times sine of angle B. Now, when B is greater than C times sine of B, that means we're going to get two solutions. So A could be equals to C times cosine of angle B added to the square root of B squared minus C squared sine squared B. So this is going to be one of the solution, or we could get the other solution as A equals to C times cosine of angle B minus the square root of B squared minus C squared sine squared B. Fine. So this could be two cases where we get two solutions, or we can say that there are two solutions that are possible. But then again, that is also going to depend on the measure of angle B. So here for case 3 itself, we are also going to get two sub cases. So here let's call it the case 3.1. So case 3.1. So here what we have, if angle B is acute, it's an acute angle. Now acute means an angle which is lying between 0 and 90 degrees. So if B is acute, then clearly sine of angle B, that is going to be positive as well. Now here we know for the triangle to exist, the side A must be positive. That means in essence we can say that A must be greater than 0. Only then the solution for the triangle is going to exist. We're going to consider this particular solution because this is always going to be positive, because since sine B is greater than 0 and is an acute angle, and we have already considered B to be greater than C times sine of B. So this is always going to be positive. So A is always going to be positive. So this is fine. So that means we are going to get one solution of this particular form where A is going to have this form. Here we need to find out all the condition that is going to yield two solutions. So here we consider this case where we have C times cosine of angle B minus the square root of B squared minus C squared times sine squared B. So we're going to consider that this is also has to be greater than 0 in order for the triangle to have two solutions. So let's solve this inequality. We have C times cosine of B. It has to be greater than the square root of B squared minus C squared sine squared B. So what we'll do, we're going to get rid of the square root. All we have to do is square both sides. That's going to give us C squared cosine squared B. So that has to be greater than B squared minus C squared sine squared B. Now, squaring both sides is not going to affect the sign of the equality. Now let's transpose negative C squared sine squared B to the left hand side of the inequality. So we get C squared multiplied to cosine squared B added to sine squared B. So this has to be greater than B squared. Now we know cosine squared B plus sine squared B, there's an identity which has a value equals to 1. So we get C squared is going to be greater than B squared. So finally we say that C is going to be greater than B, and we have already established that B is greater than C times sine of angle B. So this is the criterion. So for the triangle to have two solutions, then we need that the side C must be greater than B and B has to be greater than C times sine of angle B. So we're going to get two triangles where B has to be acute in nature. So B is acute in nature. So let's try to understand this with the help of an example, and then we will move on to the next case where B is going to be an obtuse angle. So here we need to solve the triangle whose two sides are given to us. Side B is 100 units and side C, that's 100 times square root of 2 units. Then the angle that is adjacent to the side C, B, is given as 30 degree. Clearly B is an acute angle. Now first what we'll do, we're going to verify that it satisfies the criterion that B must be greater than C times sine of angle B. It's very easy to remember. We only have to consider the side, and then it has to be greater than the product of the side C and the adjacent sine of the adjacent angle. So clearly we'll see here that B is 100. It has to be greater than C, which is 100 times square root of 2 multiplied to sine of angle B. So that's 30 degree. Now sine 30 degree, that we know that is 1/2. So we have 50 times square root of 2, and 50 times square root of 2, that is approximately 70.7. That clearly 100 is going to be greater than 70.7. So it fulfills the criterion that B is indeed greater than C times sine of angle B. So here we should get two solutions. That means we should get two triangles. So let's try to solve the two triangles. Let's consider the law of sines. So what we'll do, we're going to take the second ratio, B over sine B and C over sine C, since we know the value of the side B, side C, as well as the measure of angle B. That is going to help us find out the measure of angle C. Okay, so we have sine B over sine of angle B. That is going to be equals to C over sine of angle C. So B here is 100 divided by sine of angle B, so that's 30 degree. That's going to be equals to C, so that's 100 times square root of 2 divided by sine of angle C. So here we can factor out 100 from both sides. Sine 30 degree, that's 1/2. So when it goes to the numerator, that becomes 2. So 2 is going to be equals to square root of 2 divided by sine C. So let's solve for sine C. So sine C comes out to be square root of 2 over 2, or in other words, we have 1 over square root of 2. And we know that 1 over square root of 2 is sine 45 degrees. So that means the angle measure of C comes out to be 45 degree. Or we could have an alternative value. We could have 135 degree as well, because we know sine 135, that also corresponds to 1 over square root of 2. So C is actually either 45 degree or 135 degree, because remember we needed to find out two triangles. So let's try to find out the angle measure A. So here we're going to make use of the fact that since A plus B plus C equals to 180 degree, that implies that the angle measure of A is going to be simply obtained by finding out 180 degrees and from it subtracting the sum of angle B and angle C. So let's start by considering whenever we have C equals to 45 degree. So when C equals to 45 degree, we already know that B is fixed, that's 30 degree. That in that case, A is going to be equals to 180 degrees minus, so B plus C, that's going to be 75 degrees. So 180 minus 75, that's going to be 105 degree. And the other case when we have C equals to 135 degrees, of course B is going to be still fixed at 30 degrees. Then in that case, angle A measure comes out to be 180 degrees minus 165 degrees. That's going to give us 15 degrees. So we have obtained the measure of angle A. So let's now sketch the two triangles. These two triangles are not drawn to scale. For our final goal will be to find out the measure of the side A. So in each of the two cases, what we can do is we can take help of the law of sine. So here we're going to make use of the fact that A over sine of angle A, that's going to be equals to, we can take any one of the ratios, B over sine of angle B, which means that A is going to be equals to B times sine of angle A divided by sine of angle B. So for the first triangle, A is going to be equals to the B measure, that's 100. So we have 100 multiplied to sine of angle A, so that's 105 degrees, divided by sine of angle B, so B is 30 degrees. And then for the second triangle, A is going to be equals to B, so that's 100 multiplied to sine A, so that's 15 degrees, divided by sine of angle B, that's 30 degrees. So let's plug this into a calculator. We have already calculated the value of 105 degrees, so this should give us 50 multiplied to square root of 6 added to square root of 2. And the A measure for the other triangle is going to be 50 multiplied to square root of 6 minus square root of 2. So we have successfully solved the two triangles. Now let's move on to the final case where the angle B measure is an obtuse angle. Now let's talk about the case when B is still greater than C times sine of angle B, but we now have the angle B is an obtuse angle. Now if B is obtuse, this must mean that cosine of B is going to be a negative number. Now if cosine of B is negative number, remember we already considered A to be consisting of two solutions. So A is C times cosine of B minus the square root of B squared minus C squared sine squared b. This is one of the possible solution, but because cosine of b is a negative number, so that means this is also a negative number. So here we have a negative number, and from here we are subtracting another negative number, which makes a negative. So that means a is going to be less than 0. Now that is not possible. Now since a cannot be less than 0, so we have only one possibility, that a must be equals to c times cosine of angle b added to the square root of b squared minus c squared sine squared b. So this is the only possible solution. And also here, since cosine b is already negative, so that means the second term must be greater than the first term. So here we have the square root of b squared minus c squared times sine squared b. So this has to be greater than the first term, c times cosine of b. So let's square both sides. We're going to get b squared minus c squared sine squared b. So this is going to be greater than c squared cosine squared b. So what we'll do, we're going to transpose the second term on the left hand side to the right hand side. So we get b squared greater than, so we can take c squared as the common factor, which is going to get multiplied to sine squared b plus cosine squared b, that's 1. So b squared is going to be greater than 1, or we can say that b has to be greater than the side c. And so this is the third case. So b is greater than c times sine of b, and b is an obtuse angle, and provided b is greater than c, then we are going to get one triangle. So only one triangle is possible for this particular case. So let's try to understand this with the help of an example. So here we have a triangle with side A and B given to us. Angle A measures 120 degrees. Clearly angle A is an obtuse angle. Now before proceeding, we would like to verify whether if it fulfills the criterion for case number 3. So in case number 3, so here the sides are all changed. So what we'll have to show here, that we are given here the side B and the side A. So what we'll do, we'll take the side A and we'll have to show that it has to be greater than the other side which is given to us, that side B, multiplied to sine of the angle that is adjacent to B. So that is going to be angle A. So here we have to show that A is greater than B times sine of angle A. Okay, let's verify. So that here we have 8. 8 is greater than 7 multiplied to sine 120 degrees. Now we plug this value into a calculator. So 7 times sine 120 degrees, that comes out to be approximately 6.06. And yes, this is a true statement. So that means A is greater than B sine A, and this is fulfilling the criterion for case number 3. So here we have case number 3 with angle A equals to 120 degrees. So that means this is an obtuse angle. So here only one solution is possible. So we're going to begin by using the law of sines. Since we have the side A and the side B, we're going to use the first two ratios. So here we have A over sine of angle A, that is going to be equals to B over sine of angle B. Let's substitute the values. A, that is 8 units, divided by sine of angle A. So A is 120 degrees equals to B is 7 units, divided by sine of angle B. So sine of angle B, that is going to be equals to 7 over 8 multiplied to sine 120 degrees. So this should give us a value 0.758. Now what we'll do? We will take the inverse sine function on both sides to obtain the value of B. So B is going to be the inverse sine of 0.758. So let's plug this into a calculator, and B should be, so B comes out to be 49 degrees, 17 minutes and 18 seconds. So that is going to be the angle measure of B. Now that we have the angle measure of B, we can immediately find out the angle measure of C, because we know that A plus B plus C, that's equals to 180 degrees, which implies that measure of angle C, that is going to be 180 degrees minus the sum of A and B. Fine. So let's plug this into a calculator. The measure of C comes out to be 10 degrees, 42 minutes and 42 seconds. So that is going to be the angle measure of C. So now that we have the angle measure of C, we can also find out the measure of the side C. Again, we'll be using the law of sines here. So since we need to find out the measure of side C, we're going to use the third ratio C over sine of angle C. And then we're going to equate it to any one of the two ratios. So let's take A over sine of angle A. So C is going to be equals to A times sine of angle C whole divided by sine of angle A. So what is A here? A here is 8 units. That's going to get multiplied to sine of the angle C. Angle C, that is 10 degrees, 42 minutes and 42 seconds. Whole divided by sine of angle A. Angle A, that's 120 degrees. So let's plug this into a calculator and we should get approximately 1.72. So that is going to be the measure of the side C. So to summarize, so what we have done is if we have a triangle ABC, two of the sides are known and then one of the angle which is opposite to one of the side as given to us, then we can express the remaining side A as C times cosine of B plus or minus square root of B squared minus C squared times sine squared times B. Now, and that immediately gives rise to four cases. The first one is if B is less than C times sine of B, then there is going to be no solution, and that would mean that no triangle exists. And then in the next case, if we have B equals to C times sine of B, then there is a unique solution, meaning a single triangle exists and that triangle is going to be a right angled triangle. So that's a unique case. Then in the third case, if B is greater than C times sine of B, then this means the value inside the square root is positive in nature. And also if it's the angle B is an acute in nature, then in that case there are going to be two triangles provided the side C is greater than the side B and side B is greater than C times sine of angle B. And finally in the fourth case, B is greater than C times sine of B and B is an obtuse angle, then there is going to be only one triangle provided B is greater than C.